our worksheet. That's kind of our quick little intro about perfect squares. You should have them written down. We should kind of know them by heart. Yes. Oh, I will just grab this, the bottom one from you. Oh, sorry, the top one. Yep, thank you. So, perfect squares. The square root's easy to solve. They're a whole number. They're nice and neat. We're good to go. Square root of a non-perfect square, that's when we get to all of our decimals that are super gross, hard to work with, we don't like them. We can estimate non-perfect squares, okay? That works pretty easy, right? Kind of, sort of, maybe, and go ahead and not. Okay, we're gonna do another way of trying to figure out the value of a non-perfect square root, okay? So take a paper and pass it. If there are extras, just kind of hold on to them. I'll get them in a moment. Okay. So pass them quickly back to your other partner again. I will just take it and I'll put it off. You're wrong. All right. So you should have a worksheet. I will tell you right now that the first part of these notes, you might be like, Miss Ozer, we totally just talked about this. I know what these are. The reason why I put these into note form is so that in case one day, like, I don't know, back next in May, like right before the SOL, you completely blank out on something, you have the notes already there for you. It's already written down. Okay, so just in case you forget, because I know sometimes I forget, you have it somewhere concrete. So, I think you're really allergic to math class. Oh my gosh. So we're gonna fill in the note. This is normally how notes go. They're pretty much fill in the blank to a degree. If you can't read my handwriting, obviously let me know. I say it out loud as well. So square roots. The square root of a number is a value that when multiplied by itself gives you the square. Okay, so this is obviously how we talked about how they're related. You have the square, whether it's perfect or not perfect. When you take its square root, well, that number times itself gets you back to the square. For example, 4 times 4 we said is 16, so the square root of 16 is 4. Okay? As we learn, it's plus or minus, which we'll get to momentarily. You'll see the symbol, the square root symbol. Make sure your square root symbol has a foot. If you don't have a foot, that means division. Okay, so just make sure it has a little foot at the end. Square root of 36 works for us. So the square root of a perfect square is going to be an integer. And we'll talk about on Monday what an integer is. But all you need to know right now is a number that doesn't have a decimal. Okay, it's just our nice, neat numbers. For example, the square root of 16, we said could be what or what? Noah?
4 or negative 4.
4 or negative 4. Integers are positive and negative. Square root of 169 is how much? Yeah, I mean a 13 or negative 13. Okay, mathematicians, you'll realize as we go throughout this year and also in algebra, they get really lazy. And so some guy probably really, really long time ago was like, I don't have time in my life to write 4 twice. So they came up with a symbol that says plus or minus 4. They didn't want to write the 4 again, so they did plus or minus, and then they put the sign, the number next to it. So you might see that periodically. All right, so then we have the square root of a non-perfect square. Okay, is going to be an irrational number. It's going to be a super ridiculously gross decimal. Okay, that we don't really like dealing with. Sometimes it is easier to just give 2 consecutive. What does consecutive mean? I've said it a few times already in class today. Consecutive. C-O-N-S-E-C-U-T-I-V-E. Consecutive numbers. Or consecutive grades. Jennifer.
Isn't that like the number next?
Yeah, it's a number next to it. It's a number right after it. Okay, they're in a row. So 2 consecutive whole numbers between which the square root lies. Well, that's what we just did the first half of class. If you take the square root of 17, You look at the perfect square right above it, the perfect square right below it, and you can say the square root of 17 is going to lie between 4 and 5. Okay? That's what we did 20 minutes ago. That's all we were doing. We were estimating them. Okay? But now we're going to jump into simplifying them. Okay? We can call it simplifying square roots. You also might see directions that say simplifying radicals. Okay, this means the same thing. When you see the word radical, that's what the square root symbol is actually called. Okay? So, this idea of simplifying radicals, you don't have to copy this down, I just want to show you. If you have a test and you get an answer that says 4/8, should you leave your answer as 4/8? No, what should you do, Henry? To what? 1/2, yeah. Are these the same thing?
Yes.
Yeah, they're the same thing. One is just more simplified. Obviously, you could also do 4/8 to 2/4 to 1/2. They're all the same thing. One is just more simplified. That's what we're going to be doing with our non-perfect square roots. Okay? You might think they're simplified, but they're actually not. So, with square roots of non-perfect squares can often be simplified by factoring out perfect squares. Okay, and there's a method to my madness about how to do that if you're like, oh my gosh, I can't believe we're doing this right now. Okay, so what we're going to first do, our goal is to make these more simplified. If you left the square root of 12 on a test, I'd say, not simplified. You could do more stuff to that, just like we had with the fractions. How many of you guys remember factor trees? Factor trees, they look something like this, maybe? Okay, factor trees. Valen, what did you do with factor trees? Do you remember, or how'd you make one?
I forget how, but I remember.
You remember doing something with it? Okay, Noelle, do you remember?
Yeah, it's sort of like taking like a number and then breaking it down into its factors, and like the factor can still be broken down, you still break it down.
Okay, so we're breaking it down to factors. Factors are what times what gets you that number. So our trees only have 2 limbs every time. So right next to the 12, we're actually going to work from the right-hand example all the way to the left-hand example. Okay, we're going to work a little bit backwards. So we're going to write 12, and then we're going to have these 2 little carrots. Okay? What times what will get me 12? Abel. 3 times 4. Okay? For right now, for the sake of all of us just being on the same page, I know you might have wanted to say 6 times 2. You can later once we fully understand what we're doing first. Okay? You will still get the same answer, but I don't want you to be confused along the way. So we have 12, which breaks into 4 times 3. We're always dealing with multiplication here. Okay, can 3 be broken down, or is it prime?
It's prime.
It's prime. If it is prime, I'm going to circle it. Okay, so our goal is to get, at the end of every branch, a prime number. Can 4 be broken down?
Yes.
Okay, so we break it down again with our same little triangle, and what do we break it down into?
2.
2 times 2. And then is 2 prime?
Yes.
Yes.
No.
Yeah, no, 1.
What times what gets me 2?
1 times 2.
1 times 2 or 2 times 1. Well, if it's prime, the only factors are 1 and itself.
Yeah.
So 2, whoa, is prime. Okay? Your goal is to get prime numbers at the end of every tree. Okay, so we should have this copied down right next to our square root of 12. Are we good so far? Did I lose anyone? It's what times what gets me the number at the point. What times what gets me the number at the point. Okay. Are we good? All right, I'd like to put your pencil down for a second. I'm going to tell you a story. Okay. So, the disclaimer for the entire year is that 99.6% of the stories I tell you are true. The other 4.4%, I probably just make it more exciting. So I really enjoy camping. 100%, it's one of my favorite things to do. I go with a bunch of friends. I was in Girl Scouts. Always loved to camp. When I go camping, when I was in college, we were kind of poor college students, and I had like a big group of friends, so we bought one big tent, and we all slept inside of it. It's because it's what we had to do. So when we all go camping, there are boys and girls. I know boys have cooties, but sorry boys, but it's true. When we go camping, have you ever, whether you've been camping or like even in the middle of the night, have you ever woken up in the middle of the night, like at midnight, and you're like, ugh, why would I have an frustration when I wake up in the middle of the night? What do I have to do? Anthony? No, I don't have to go back to sleep. I woke up for a reason. Why did I wake up, Carson? I had to go to the bathroom. Okay? It happens every time I go camping. No matter how hard I try, every time I always wake up in the middle of the night and I have to go to the bathroom. When I was younger, there was a bear at a sleepaway camp that I went to, so I'm officially afraid of bears. If I'm going camping, I never go anywhere without a buddy. So if I wake up in the middle of the night, I need to bring a buddy. I need to wake someone up, and I need to bring a buddy. They're always mad at me, but they're my friends, so they still love me. Okay? If I'm gonna wake someone up in my tent, remember it's boys and girls, who should I be waking up to go to the bathroom with? A boy or a girl? A girl, right? Probably more logical, even though they're probably also scared of bears. At least we're together and we can scream really loud, so it's fine. So I always go with a buddy. I always go with someone who's exactly like me right now in terms of gender. Okay? So, what does that have to do with anything we're doing now? Because we just talked about going to the bathroom in the woods. Okay, John, hold on. Alright, so I lost all of my markers. So what we're going to do, we first started off with our factor tree. Okay, you can pick up your pencil now. Alright, we have our tent. It's a very fancy tent. There's a lot of room inside my tent. Okay, all I did was write my 10 underneath my 12. Okay, perfect. We are going to fill this tent with our prime factors. Okay, 3 times 2 times 2 gets me back to my original 12. 3 times 2 is 6, 6 times 2 is 12. I didn't change anything from what I started with, besides the fact I broke it up into its factors. So far, so good. Okay. If someone wants to leave the tent, they have to have a buddy. They have to have a number that is exactly like itself. If they don't have a buddy, they stay in the tent. Does 3 have a buddy? No. It's going to stay in the tent. Does 2 have a buddy?
Yes.
Yes, a buddy is only a pair of 2. Not the number 2, but the amount of 2. If the 2 can leave the tent, they form one group of that number. When me and my friend leave the tent, we form one group of people that have to go to the bathroom. So my 2s leave the tent, they form one group of 2s. And then who's still under my tent? 3. Okay. So we had factor tree to rewriting the tent with our prime factors, finding our pairs. If they had a buddy, they could leave. If they didn't have a buddy, they had to stay. And now here's where the whole hocus pocus magic, oh my gosh, my teacher's a witch thing happens. With your calculator, I'd like you to hit the square root of 12. So 12 square root. And then raise your hand, tell me what the decimal is. Laura, what'd you get?
3.4.
3.4. And by estimating, right? It goes on forever. Yeah, okay. That's fine. We'll just have an estimate of that right now. We could probably have guessed it would be between 3 and 4 because it's between 9 and 16. Alright, what I'd like you to do, all multiplication here. I'd like you to find the square root of 3. The square root of 3. So with your calculator, you should do this. And then multiply it by 2. And what do you find, Henry? 3.4, whatever. It is the exact same thing. This is our simplified answer. With someone on the outside, someone on the inside. Okay? And that's what you would write if I said simplify the radical. That's exactly what we were doing when we were going from fraction to fraction. Exact same amount, just looks different. All right, so we're gonna jump down to number 50. Okay, with number 50, we're gonna do, what are we gonna do first? What are we gonna do first? Jonah? Factor tree. All right, factor tree. What do I wanna break this into? Noelle?
25 and 2.
25 and 2. Other Jennifer, what do I wanna break? 2 is prime. What do I wanna break 25 into? 5 and 5. Awesome. Is 5 prime?
Yes.
Yes. So we're going to circle those as well. Okay? If you decided to break it up into 5 and 10, you would also still get the same factors. So now we have square root of 50. Then what do I do? Then what do I do, Laura?
Draw your tent.
Redraw my tent with my factors underneath. So 5, 5, and 2. So we're all happy. We're all in our own sleeping bags. It's very exciting. All right, and then midnight happens. What happens here? What do we do next? It was not talk today. So 9, what do I do next?
You group them.
Okay, how do I group them?
5 goes with 5, and then 2 stays.
Yeah, the 5 has a buddy to leave the tent. They're cool. So they're going to leave the tent. They form one group of that number. One group of that number about to go to the bathroom. And then our 2 is left underneath our 10. We're going to double check the work. So right now with the square root of 50 in your calculator. Okay, we should get 7.0.
0.
Oh, 7.
Blah, 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 right? Okay, now I'd like you to hit the square root of 2 times 5. Do we get the same thing?
Yes.
So, if you're asking me all the time, now did I get the right answer? Did I get the right answer? Well, I'm going to say you can check your own work. On your homework tonight, this is going to be the second part of it. You can check your own work. If you still don't know how to do it, then yeah, obviously ask questions. But if you want to know if you got the right answer or not, find this number, and then find this square root, and multiply it by the group on the outside. Okay, what I'd like you to do, take a minute or two, and I'd like you to do your factor tree for 128, however you see fit. So right now, you do your own factor tree for 128, and this one's going to be a little bit different than the other ones. Okay, so I'm just going to erase this. And this factor tree will also be obviously a little bit bigger. Awesome, I see some people doing 64, I see some people doing 32. Whatever numbers you do, if they're different than your partner's, you'll still get the same factors if you do it correctly. So what times what gets you to that point? You can use the calculator if you need to. Look up when you're done with your tree so I know you're good to go. Factor tree. Okay, awesome. Some things to keep in mind, during my second period, I forgot one of these 2's, so what I'd recommend is that you're definitely circling them as you go so you don't forget any. Sometimes they get like sandwiched in all the tree and then you lose them and then bad news bears and then it's not good. So, how many 2's do I have? Noria. 7. I'm going to rewrite all 7 of them. 1, 2, 3, 4, 5, 6, 7. It's a huge party in this tent. Big party. Everyone's there. Okay. So then, where's this? All right. What do you notice about this problem that's different than the other problems we've obviously dealt with? Isabel, what do you notice that's different about this problem than the other two?
They have more twos.
Yeah, there's more groups, there's more pairs that can leave the tent. That's okay. There can be more than one group that has to go to the bathroom, like we don't discriminate against going to the bathroom. Okay, so what we're gonna do, we're gonna underline our groups, just so that we can keep track of them. We have one group of two, we have a second group, and we have a third group. There is one, two, that's left by itself, okay? It's sad, but it'll be stuck in the tent. All right, if they leave the tent, if there's more than one group that leaves the tent, they get multiplied. Remember, we're doing all multiplication here. They get multiplied with the other groups that have left the tent. So first we start off, this group, one is left. Where's my other one? I don't know. This black group leaves the tent. They form one group of two. Then this green group leaves the tent. They form another group of two. Then this red group leaves the tent and they form a third group of two. They're all outside of the tent. And who's still inside? Yep, the other two. So we still have to draw our tent and have our two inside. When we simplify radicals, everything is multiplication. So on the outside, we have one group, two groups, three groups. What is 2 times 2? 4. What is 4 times 2? 8. So there's actually 8 on the outside, and square root of 2 is still up on the inside. Okay, so if there is more than one group that has to leave the tent, and they're allowed, they get multiplied together on the outside of the tent. There could also be more than one person that's stuck in the tent and not allowed to leave. Well, if they're stuck in the tent with other people, they also get multiplied together under the tent. Okay? Yes?
What if there is, what if nobody ends up in the tent?
So if no one ends up in the tent, meaning everyone left, right? So what if we take the square root of 9? Just for fun, we all know what's the answer to square root of 9? 3. Well, if we do the same idea, 3 and 3, right? Same basic tree. We then break it apart, 3 and 3. We know our 3's can leave, but no one's left in the tent. Well, if we get no one left in the tent, we know that number was a perfect square. There's then the flip side of it. What if, let's say the square root of 13. Does 13 break up into anything? No, it's a prime number. Well, if it's a prime number and it can't be broken up, everyone stays in the tent. They're not allowed to leave. You're stuck. And that's our answer. That's just like if we got an answer of 1/3 on our test. Can you simplify that? No, it just stays as it is. It's in its most simplified form. Okay? All right, so flip to the back. We're going to do some practice. All right, but before we begin, we got to fill in our once upon a time story. Okay, so these are our little 4 steps to remember how to solve simplifying radicals. So what was the first thing that we did? Ava, what was the first thing that we did? You look back, what was the first thing that we wrote down? Perfect. Number 1, make your factor tree. If you run out of room and you want to do them on a separate piece of paper, you're more than welcome to. Number 2, Zakeen, do you know what we did after we made the factor tree? Yeah, we circle the prime numbers. That's part of our factor tree. I would agree. Yep, definitely circle them. What after we circled them? What did we do? Jennifer, you like ready? Kind of? No? Okay, right before we broke them into pairs, Laura?
We put our prime numbers in a tent.
Perfect. We're going to rewrite our tent number with our prime numbers. Okay? What I write on the board It's just kind of a shorthand usually. If you need to write more, by all means, you're more than welcome to. Whatever will make sense to you. I said rewrite 10 and then I used prime. If you're not going to remember what that means, use your own words. Okay, that's like good note-taking skills. All right, so we did our factor tree. We rewrote our tent. Then what did we do? We looked for what, Jennifer? What did you say before? We broke them up into groups of how many? How many? I'm only not that old. I don't need hearing aids yet. So how many? Groups of how many? 2. Okay? So we're going to find find pairs or find your buddy. Okay, we're going to find pairs, groups of 2, not the number 2, the amount of 2. You're looking for a pair. All right, and then our last step that we sometimes might have to do, sometimes might not. Anthony?
Multiply all the groups if there's more than one.
Yeah, so we're going to have to simplify the outside, or maybe even the inside of the tent if there's more than one group that leaves. Okay? I'm also going to put a little multiplication dot next to the word simplify. Okay? That's to help me remember that everything we do is multiplication when we simplify radicals. Okay? So if there's more than one group that leaves outside, you multiply all those numbers together. If there's more than one person that's stuck inside, can't go out, you multiply those numbers together. Okay? Really good. All right. There are 2 things I need you to change on this. Okay? First thing, you can scratch out the square root of 50. We did it on the front hand side. You don't need to do it again. Unless you really want to and you have extra time. Okay? The second thing that I'd like you to do, this was my own typo, I'd like you to change 38 to a 48. 38 to a 48. Okay? I'm going to give you guys about 10 minutes right now to do these problems. We've talked about the square root of 9 before. We even talked about the square root of 11, kind of, sort of, and what happens in that scenario. If you need help, look back at your notes. That's your first line of defense. Your second line of defense is to talk to people around you. Then your third line of defense to figure out what just happened in this class is to come talk to me. Okay, and I'll be kind of floating around. All right? So, you have about 10 minutes. I'll put a little timer on the board so we don't run out of time. Okay? And you have time to work on those 5 problems. Okay? Awesome.